All right, thanks, Ryan. And yes, I was a professor, well, what Americans call a professor. I was eventually a reader at the University of Edinburgh. I was there for 10 years working on neuroscience and brain science. And a lot of the study of a lumpy sphere turns out to correspond to the lumpy sphere we live on. So a lot of the visualization tools we developed there in academia kind of ported over naturally to earth science. And so that's how I got my first kind of link into working with Pangeo. And as Ryan said, we've been doing this for quite some time and had a lot of iterative improvements over the years. And I'm here to tell you about the currently new stuff you ought to be excited about if you're a current user, and the reasons you might want to consider it if consider these tools if you looked at them before, because they're doing completely new stuff now. And so I'll really focus on the new stuff, but try to do some background reading if I'm starting too high and focusing only on novel and you need to really go back to basics. So I'll touch a little bit on basics and then dive into new stuff. And I work at Anaconda. All the team that I pay for or that are salaried work at Anaconda. But these are open source projects. They're not controlled by Anaconda. We're applying for status as an independent entity, and so there's no revenue involved here. These are funded entirely through consulting work in my group. If somebody needs new features or have it applied to their problem, that's how any of this gets paid for. And so we're on a variety of different grants, working with different government agencies and different companies. So HoloViz originally started in our academic work, and then a lot of us got hired by Anaconda. We renamed it to HoloViz to emphasize that it's independent of our original neuroscience area. And there are a lot of tools. It's very confusing. And the important thing to think of is pretty much everybody should start over here in the left corner. Either if you are wanting great tools for plotting and then maybe eventually build up to a little app that you can play with, start with HVPlot. If you say, oh, right from the start, I want to build an app. I want to build a complicated thing that encapsulates my research or communicates my research, then start with Panel. Both of them are okay as starting points, but depending on whether you're married to an app or you're married to plotting, that's which one you start with. And these all build on the rest of these tools here. For instance, if you have very large data, they'll automatically call Data Shader when you tell them to render it onto a limited resolution on your screen. So if you have very large rasters or whatever, you'll use Data Shader to make it feasible to work with. But let's just ignore all of that and really focus on Panel and HVPlot for this talk, because that's really where most people should start. Looking at HVPlot, basically, if you've done dot plot on an X-array or a pandas object, HVPlot is the same thing. It uses the same API, but then tries to build a lot of power on top of it. Those two, the usual default implementations of those plotting routines are on Matplotlib, which is very full-featured, great for publications, but it's pretty limited in terms of its interactivity. And so the first thing these give you is bokeh-based plots that are fully JavaScript-based, interactive in a web browser. So you can pretty much explore to your heart's content, often without even coding. And they also support Plotly. What's new is that actually, I'm starting at the bottom here, but what's new is that HVPlot was built on tools that supported all three of those plotting libraries, Bokeh, Matplotlib, Plotly, but it really only supported Bokeh until quite recently, and now it supports Matplotlib and Plotly. And why that might be important is if you really want to control the look and feel, particularly if you want to generate things with HVPlot and then add them to other things you generated manually with one of these other tools like Matplotlib, put it together and put it in a publication, trying to make there not be a difference between, oh, I'm quickly exploring something in a web browser to eventually publishing your results. And another thing that's new, by the way, right now I'm going to go through some slides, and then with the remaining time, I'll do live demos until time runs out. So for now, we're just doing the high level. And HVPlot comes with some newly expanded feature called .interactive. And the easy way to think about that is if you do X-array data set or data array .something .something .cell .aggregate .whatever, that whole thing anytime you have a parameter in there, you can pop in a widget, and then it becomes an app kind of magically. And I'll demonstrate that. And that's very little code involved. But what if you don't want to do any coding at all? We now ship with the Explorer. And what that lets you do is pop up a data set and then choose your axes, choose your type of plot, and kind of dive into the explore what's interesting to see. And then you can get it back out as a bit of code that you paste into your notebook. And that's what you can start working with at that point. So kind of a no code approach, even though this is all for coding. So that's HVPlot. It'll take you from plotting to limited types of apps. Fairly impressive, but it's meant to be really focused on apps that are about a data set. And then Panel is what's going on behind the scenes for HVPlot. When it's making a little app with a slider, that's all built on Panel. And what's really cool about the new Panel release is you can save your app to pure HTML and put it on a web server anywhere, just a standard web server that doesn't even have Python running, and it'll run Python in your browser. And that makes it super easy to share your work now. It also makes it super easy for us to share our work because the Panel website and gradually our other websites are becoming live with, when you visit the website, it's just a standard web server hosted like any other standard web server hosts things, but you can run live Python code in the browser. So you can try out our tools a lot more easily than you could before. So I'll get to, well, I'll come back to what the roadmap is after I show some demos. This should be the last slide, so remind me to come back to that. And also, just as an aside, if you don't like what you see today, go to pybiz.org, and you've got lots of other options other than HVPlot. You'll find all the Viz libraries there. So I'm going to really focus on HVPlot and Panel, but everything else for Python is just listed there. All right, so I'll come back to the roadmap. But what I'm going to do now is say, if I've spoken too quickly, go to holobiz.org. There's a detailed tutorial. They'll step through all the steps I'm skipping over today. So when I'm trying to focus on new stuff. And what I'm covering is mostly covered in these 2 blog posts about the new HVPlot release and the new Panel release. Just go to blog.holobiz.org and you should be able to find those to study them in more detail. So diving in, HVPlot, that's at hvplot.holobiz.org. Just as a super quick example, let's say you've got, imagine you've got an Xarray object, in this case, just the standard one from the Xarray tutorial. It's a data set, it's a multidimensional array with various dimensions. This all also works for columnar data and pandas, but we'll mainly focus on ND arrays for this talk. And if we select some bit of that data, in this case, it's a 1D slice. You could just call it HVPlot. We could have called plot, and that would have given us a static plot in this case. But we didn't. We called HVPlot. And we got an interactive plot that we can hover and so on. But the cool thing is, skipping ahead, kind of to the reason you use HVPlot is mostly that it handles multiple dimensions very cleanly. And if there's one not mapped onto the screen, like latitude and longitude, there's also time. It's really easy to get a slider to just work with that data. So if you have a stack of data along many dimensions, you'll end up with a lot of different sliders here. So that's the basics for how anything works. And then you go flexibly back and forth between ND and slicing it down to a time series. But here's the new stuff, which is, okay, here's the example of using it to get matplotlib. So this is, probably ought to restart here. This is, I'm stepping through the blog post right now and just showing you the basics of selecting your backend. In this case, it's by default, it's bokeh, but now let's say we want matplotlib plots. In this case, that's all you have to do. You choose matplotlib, and then your subsequent plots when you do HVPlot will be in matplotlib. I've probably redefined something here, so it doesn't make a very good demo. But in any case, what you can do is, since it is Matplotlib, you can now doctor it and do whatever you want because you can get the Matplotlib figure. And so I'm just imagining somebody taking this and putting it together with other Matplotlib figures and making your fabulous nature paper. So probably here is, so moving on, so that's the multiple backends to being demonstrated. This is the .interactive support. Here's the kind of simplest example. If I start with that same Xarray sample data set, we just add this one little thing called .interactive. And then whenever we have a parameter, we can stuff in a slider in this case. So we can very directly, if you're aggregating or selecting or doing anything, anytime there's a parameter, you put in a slider for that, and then you get an instant app. And so in this case, we have an app for measuring, taking things at a certain quantile. But it can be anything, literally anything. And then what's new, that's pretty new, but then what's extremely new is this last bit here. Well, let me go back. So notice that here we started with an Xarray data set. What if you need to select from a disk full of Xarray data sets as netcdf files or whatever they are? That's what's particularly new. Get out of my way. And here, what you do is you write a little function for that. One-line function is okay as long as it's got some parameter, and that parameter you make a widget for. And then you use what's called hvplot.bind and bind this this widget to this function. Hopefully that makes sense. What it means is you've got a function, it takes an argument, and you're using this command to say this argument should be given the value of this widget, and then you'd call .interactive on that. So that gives you a little bound function object. Sorry for the jargon, but what it is a thing that whenever you change the widget, it's going to recall that function. And so in this case, it's driven by a ticker. It's not a very relevant example here, but whenever you change this one, it invokes this function and then replays this entire pipeline. So if you change these guys, these are pretty quick because they're replaying parts of the pipeline down low. So you're starting with your data, doing some sort of selection here or resampling, and then a plot. And whichever one you change of here, that's going to update the plot. And if you change this one, it's going to call this function again. Hopefully that makes sense. Basically, it means you can pretty much build any app you want using only hvplot. You don't have to learn anything from Panel. It's going to get harder and harder the more complex you get. And at some point, you're probably going to want to learn Panel and switch to that. But you can build up to anything. So whatever it is you care about your data or your research, you make a widget for it and then explore the results. Okay, the last new thing for hvplot is the Explorer. And the Explorer is exactly what you think. If you give it a data set, it'll let you explore it. So in this case, you select what goes on X and Y. Now this is a kind of boring example here because it's the sample one and there's not much to explore. You can do things like you can update, you can pretty much customize your plot. Normally, if I have time, I'll show another example that's with pandas. The Xarray support for Explorer is brand new and not released. Apologies, I thought it'd be ready for today's talk. But as you can see, you should normally be able to select the axes, what you want to show and what kind of plot, whether you want an image or whatever. And then it'll update. And here we've selected that. And then when you're done and you finished exploring, you found something amazing, you're ready to publish it. You do this, you grab the code, and you'll see now it's pulled out the fact that I changed the title to the title. If I go back and delete that, then that's no longer there. So basically it'll let you play around with it, put anything on anything, plot anything against anything. And when you're done, you grab this and that's what you paste in your notebook. That's what you end up publishing. Or really what you're going to start working on now, and you're going to fiddle with it by hand, but you got there quicker using the Explorer. Okay, that's it for hvplot. Panel's a lot easier to demo. Basically, Panel has lots of ways you can build apps, but here's a particular way. You put it together out of rows and columns, and you here's a function here, and it's given these values. It's pretty similar to what you do in htplot. You get 3 widgets. You bind the widgets to the inputs of this function, and you put it together in some rows and columns. You get a little app. So this is just some demo app. A great little app, but it's just a demo. But the cool thing is you save it to a Python file. I called it script.py. You run panel convert to that. And then you can take the result of that and put it on a, you can start a web server, or you can just take the file that results and put it on GitHub or any other web server anywhere, and then just visit it, and you get this. This is that same app. Look what happens here. As you are, just hit it reload. It's installing scikit-learn in my browser, installing pandas in my browser, running the app. And now it's live in my browser with no Python server running anywhere except Chrome. So this is just running in Chrome. So the workflow there is build a little app, make it work in Jupyter, save it, export it, stick it on GitHub or literally any web server anywhere, and then anyone can come use it. So you can explore Panel, find out everything else. There are limitations to this. They are almost entirely built. The limitations are around what does the browser support and how can we get around the fact that things aren't supported. Right now, the data is a big deal. If you stick your data on S3, you should be able to pull it in. If you try to access a database that's authenticated, it's going to be very tricky because you just have a little file. You don't have a server running that can handle authentication. So there are limitations, but pretty much everything is running. Data Shader won't, unfortunately, because we don't have Numba compiled to run on the web browser yet, but it will be, I believe. Oh, the last thing to show then is live websites. So if we go to a web page on Panel, this is something that everyone should consider for their own code they want to share. This little green button here, it says, executing it will download a Python runtime, 40 megabytes. Click again. So I will do that. I click again, it tells me it's loading all this stuff, executing the code. And now everything in here is live. So it's just on a standard web server. The web server doesn't have any special Python process running. There's no auto scaling for servers in the cloud, none of that. This is running in your web browser. So you can really easily demonstrate your work to everybody. Okay, I think back to that, what's next? You should expect to see higher velocity. We had 3 people on the HoloViz team at the beginning of last year. We currently have 10, so I'm going a little bit crazy. I think that's 12 as of, it'll be 12 very soon. So we have a lot of people doing a lot of work all the time. So some of those people are going to be working on better documentation, which I think is super important. More immediately, we're going to be releasing Xarray HVPlot Explorer. I asked Maxime who's working on it. He said, 2 weeks. I said, well, there's Thanksgiving. So really, I would say end of this year. Because 2 weeks, if it slips just a little bit, there are only a few weeks left in the year. We can announce that we just got a grant from CZI, Chan Zuckerberg Initiative. It's focused on biological data, but we're implementing it at a general purpose level. It's just better support for gridded data of any kind. And all our examples will be biological data, but it's going to be about fundamental transport of bytes around. How fast can you do that? How easily does that work? Plus various different ways of visualizing things, working with them. We're also deep in the middle of anytime you show a plot, being able to annotate on that plot and collect it and then do anything, either just restore it later or look anomaly, or even do machine learning on little bits that you've notated. So that should come real soon. If anyone's used Datashader, you'll know that it turns data into an image basically, and then, oh, I've got a beautiful image and that's it. But we're changing it to collect the indexes of the data as it's done it, so that now when you see the data, you should be able to hover and click over it and get right back to the original data set. So it should full support for bokeh style hover and drill down. Last bit, Bokeh 3 just came out. That's a complete re-implementation of how it lays out plots and widgets and whatever. That's all been redesigned to use your web browser to do all that work, which is great. It's what should always have been the case once web browsers start to get really good at that. But that's not how it has been done. So many things are breaking, and we're going to try to have that ready by Christmas, but I don't know if we're going to make it. In any case, please follow, if you're interested in any of this, look at all the examples at examples.pybiz and follow the tutorial at holobiz.org. Thank you.